That would be great.
Cool. Let me I'm trying to arrange this in a way that I can see you guys here. Hi everyone, thank you so much for well, showing up for this. Can anybody nod if you can see my screen? Yeah, thanks, just checking. Okay, so I'm going to present. I'm usually, you know, those of you who know me, I usually do lab stuff or simulations. So this is very sort of in terms of methods out of my comfort zone. But because there's only one thing that I know how to do is, which is look into how people search. It's still about that. And it's not super early work, but it is very much work in progress. I've basically just finished writing sort of first draft of this. So any comments would be sort of very much appreciated. I also thank you, Carsten, for suggesting that this is recorded, because I very much want to listen to your input. So the title is "What Do the Experts Know?" It's inspired by what does the fox say. That's sort of the thing that comes into my mind when I read this title. But it is also inspired by sort of a question of, you know, knowing that there's something about adaptive search. We know that humans search when they're trying to solve problems, and we don't quite know. As you'll see in a second, what experts actually do. Let me see if I can actually change my slides. So this is work carried on with a bunch of really smart people. Some of them from Harvard, some of them from HBS. I want to particularly mention Rinat and Haley, which are these sort of guys here, because they have been really instrumental in getting a sort of helping me make sense of what is really a cool data set, but also a very messy data set. That's also why an empirical investigation is in the title, because this is very much out in the wild kind of data, the data that was not collected with the purpose of doing research on it. So that entails a bunch of complications. All right, so this is a bit of a background, and as I said, what I do, and this is basically what I've been doing for a long time now, is I look into search as problem solving or problem solving as search. For those of you who haven't heard me talk about this before, I will sort of give a bit of background. For everybody else, I apologize. This is very boring. But basically, I'm looking into problem solving as a sequential process. And this is a particular kind of problem solving. There are other sort of ways of looking at this, but I'm looking into that. And also, I'm particularly interested in this choice between, you know, exploration, exploitation, between I don't know, you know, looking for or going for the familiar versus going for the unknown. And there's a lot of places where this choice comes in, and then, you know, there's a bunch of examples. For whatever reason, this idea of choosing the restaurant to eat at keeps on popping up in the literature. Apparently, it's an important choice that we all have to make. But there is something about, you know, when you're trying to solve a problem, you know, are you going to go more in depth with what you currently know to be a good enough solution, or are you going to try something else? And you also need to sort of be maybe, or I need to specify or to clarify, we're talking about problems where the solver is not aware of the optimal solution, nor is an optimal solution sort of so it can't be solved analytically, basically, right? So it's really a search in its most fundamental way. And these kinds of things have been studied extensively in the lab, usually by or sort of more cognitive science, but also economics, resorting to some kind of arm bandit, where basically the choice is, you know, where you're going to use the same arm that gave you a good payoff before, or are you going to switch? And how do you actually maximize the cumulative payoff? But also by sort of resorting to other kinds of combinatorial puzzles. This is a screenshot from a game that well, Mirza and Karsten know very well. And the usual caveats apply with respect to studying this in the lab, right? There's something about external validity. There's how do people actually react or would respond to solving or dealing with a problem where they can generate solutions themselves rather than choosing some predetermined kinds of solutions and so on. So there's a lot of caveats that come with this, but of course there's also quite a lot of sort of advantages. We all know or a lot of people that are present today do lab studies. What I would say is one of the main things that I sort of or whatever I want to discuss here with respect to the lab studies and their limitations is the fact that here expertise and expert behavior is very hard to sort of capture in these kinds of tasks, right? And of course, expertise has been studied extensively in tasks in cognitive science, where we're talking about chess and chess experts and so on. But when it comes to these kinds of things, we don't actually have that much research. And also actually outside chess, I didn't really find that much research talking about how people actually search and how experts, people who have domain knowledge, actually search for solutions for solutions, period. So despite the fact that this has been studied quite a lot, we don't really know much about expertise in a very sort of fundamental way. And then there's this dichotomy, right? There's this not paradox, but there is this tension between, do we believe that experts can bring something to the table, or do we believe that it's really just about luck, or it's really about I put here, this is a sort of a slide that will be more popular in business schools. This sort of Simonson reference is probably more familiar for you guys, but there is this sort of debate there, do we really need experts? Do experts actually bring something extra to the table, or is it just that they are sort of somehow more lucky maybe in the beginning of their trajectories? So basically what I want us to look into is, is there something special about expert search behavior? In our literature and organizational literature, we would say that experts should actually search further away than non-experts. Sort of, let me see if I have this and if it works. It does, yes. So the logic there being that experts, they form some kind of mental models of the problem, and that they actually navigate the landscape better. Now, if we were at IMC, I would ask you to nod if this idea of problem landscape is familiar to you. I know for some it is, but in the absence of feedback, I will assume on average people are familiar with it. Okay, Andreas is shaking his head. So the idea with the fitness landscape is, when you're trying to solve a problem, you can think of that problem-solving process as navigating just an actual landscape, but you're navigating that landscape through a thick fog, so you can't actually see where the highest peak is. And if you imagine that you're in some kind of landscape that looks like the Himalayas, like Mount Fuji, where you just have one peak, then it's easy enough. You just walk, and as long as you're climbing, that's a good thing. You can continue on that path. But if you are somewhere in the Alps on something that is a little bit more rugged, like this here, then the fact that you don't really know whether you're on this tiny peak here or on the actual peak here, up here on the whatever the highest peak in the Alps might be, then that actually, you know, makes people get stuck in suboptimal solutions. Right, so that would be sort of this fitness landscape metaphor. And the idea here with the experts is that the experts would have a better understanding of the topology. They would have better mental models that would actually allow them to know that, you know, we are really in a suboptimal solution. There are things that we can actually do better to get to a higher peak than where we are right now. And that's supposed to be captured by this GIF here, that for an expert, any landscape is actually flat, so it's easy to navigate. You don't really need to worry about being trapped in some kind of suboptimal solution. I don't see I don't see a chat here. Okay, now I see it. If there are any questions along the way, please feel free, and especially now that I just explained this fitness landscape thing without being able to see people in the eye, to see how many of you I have lost. Please ask questions in the chat. Cool. So the idea here again is experts should be basically able, you know, you can think of experts as people who have, you know, a deep topological knowledge. So they will not be somehow accidentally stuck in some tiny peak, but rather they will always know, well, no, wait, we need to go further. We might have to, you know, go in some deep valley, but we need to go further if we are going to reach. I keep on not being able to come up with a peak for the Alps. What is a good peak for the Alps? Whatever, if we're going to reach Mont Blanc, thank you. If we're going to reach Mont Blanc, we need to actually keep on going further, right? So that's the idea with the experts' search behavior. So now this is not only, and these are probably some slides and references you might recognize from you know, your cognitive science education. So this would be supported also by some of the research, like the classical research done in cognitive science, where there's the discussion about fixation, which I'm a huge fan of, but largely the idea is it's only the super experts are actually not going to be fixated with their previous successful solutions. Rather, they would be able to figure out, you know, the proper ways of the proper problem representations that would actually allow them to solve the problems. It also seems that looking at chess in particular, experts would search deeper and broader. So again, the idea is experts should actually, even also according to this kind of research, search further away than the non-experts. They shouldn't be sort of limited by the smaller peaks. So this would be sort of a hypothesis about how far experts should search. But problem solving is, as I said, a sequential process. So I also wanted to look at whether expertise influences sort of the sequence, or how more the trajectory is not just the distance where people go. So I moved to this idea that is ubiquitous across sort of disciplines, sort of meta-heuristic, that says if you're doing well, you should stay. If you're doing poorly, you should move away. And we find this in computer science. We find this with pigeons, not so much with rats, but apparently also rats can be sort of nudged to do this, but they're more sort of likely to do the opposite. But we find this everywhere with animal foraging and so on. It's a very common heuristic too that actually seems to be working reasonably well. And we also managed to, well, we also find it in organizations. Actually, this is a famous paper, at least in our field. We also found it in our own work with Jakob Schersen and then their group, when we are trying to see how people were trying to find a solution for very complicated quantum physics optimization problem. So it seems to be that people do this, and this is a very good domain general heuristic, that when you're doing well, you should be sort of sticking to whatever it is that you're doing right now. And when you're doing poorly, you should make big changes. This is also, by the way, in line with prospect theory, right? So if I'm doing well, I don't feel the need to take any risks, but if I'm doing poorly, I will be more likely to take on additional risks because I got nothing to lose in a way. By the way, it seems that humans are a bit more like rats than they are like pigeons when it comes to this, that people do this, but they are a little bit more prone to do big sort of changes than they should. Sometimes this is useful for performance, sometimes not. And then the question is, are expert solvers also sort of behaving like this? Do they behave according to a win, stay, lose, shift strategy? And hypothesis would be that they don't, because this, for all its benefits, this win, stay, lose, shift is sort of this is also why it's very sort of popular all over the place. It's a little bit automatic, right? If you're doing well, you should be staying put. If you're doing poorly, you should just make big changes. Rather, the hypothesis here would be that expert solvers have enough domain knowledge that they can interpret feedback better, and also maybe are more prone to have somewhat more well, feedback independent strategies of searching the landscape. So that would be sort of the hypothesis with respect to this. Now, the data that we're relying on, and this is where we get to the part where I can probably give way too many details, so please stop me. But the data that we're relying on comes from a online platform called TopCoder. TopCoder has basically created a business model around recruiting a bunch of programmers around the world and giving them different programming challenges. In some of these challenges, there are prizes, in some of them they're not. But basically what TopCoder is selling to different clients, famously to NASA at some point, is the ability to sort of give them solutions to whatever programming challenges they would have at a small price. And they attract a bunch of really skilled players, but obviously they also attract actually a lot of people who are just trying to learn or trying to figure out how would you deal with any kind of programming problem. So they have the programming challenges. They have sort of kind of this format where there's some problem statement, there's there's some requirements. Anybody can participate, and for the most part, you are actually allowed to submit as many solutions as you want. There are very few challenges where this is limited, if there are some big data science challenges. But for the most part, people actually submit multiple times, and they get a score for their submissions. Now, it's not always the score that they get for every submission is not necessarily the final score that they would get, but in some, or for the most part, in the challenges that we're looking at, it is actually a pretty good signal for their performance. So that's basically sort of the setup, and what should I say else? So they compete for a prize or just for some reputation. And then what we have is basically all of their submissions that kind of look something like this. So we have the problem statements themselves, but also something about the coders. So what we're looking at is basically this exploration expectation balance, which we capture as structural changes in codes versus more minor updates, because basically we have, as I said, all their submissions throughout the given challenge, so we can see the differences between one submission and the other, and we actually look at different kinds of changes. Then we look at, we include, well, at least in this presentation, I'm really focusing on very simple sort of variables. I just look at feedback as or if you prefer, sort of aspiration levels or whatever. So we're just looking at how people have performed in the past with respect to their own historical performance or with respect to the others in the competition, because there's a say a bulletin board, or not a rank, so they can see what the others have done, so they can compare their performance with the best in a given competition. So obviously that is sort of a way to think about whether are you doing well or are you doing poorly, but also your own historical performance should matter. And then they have, and it's publicly known, a ELO-like rating, which basically gives them the skill on the platform. So these are also the main variables I'm looking at. How do we measure the changes in code? Well, basically from any given submission, we took an abstract syntax tree representation, which is, well, looks something like that. But basically we've taken the major structural things in a given piece of programming and compare, you know, the initial submission with the middle submission and the middle submission with the last submission for changes in this structure. And we've only actually looked at sort of with respect to what counts as a structural change. We've only actually looked at class deletions, class insertions, methods deletions, and methods insertions. So like really big, major sort of structural changes. And then conversely, for the updates, we have actually only looked at what happens within these sort of elements of the code. Now, if you're not a programming person, we made some assumptions and we try to capture structural changes in a meaningful way. Like, I think that's how I could explain it at the best. This abstract syntax tree thing is not something that we, and the differences is not something that we have developed ourselves, but it is Haley, one of the co-authors, that has actually developed a way to do this for big sort of databases. And as well as the measure we have used. Most of our results are measure agnostic. Yes, Carsten.
So just a clarifying question. So does this difference between structural and changes and updates map on to exploitation and exploration, or
yes,
distance? Yeah, okay. So those two are supposed to map onto each other.
Yes, that's what we try to capture. It because so for the updates is basically changes within these sort of structures. Yes.
So, but could you imagine updates within a structure that are so significant that they are sort of someone searching far away from the original solution, but they would be categorized as updates?
I mean, I could imagine, but on average, I would say not according to this representation, because what we've taken to be, so basically this abstract syntax tree thing, what it does is actually takes and represents the entire code as nodes. So we're only, and we are looking at, you know, whether a node representing a method has actually been deleted or inserted or whatever, or whether within that there has been some kind of change. So in principle, I mean, of course there's limitations to the, but we really try to do our due diligence to exclude these cases.
And on average, I follow what you mean. Thanks.
Yeah. Sorry. Yes. So that's a, I mean, like all the results that I'm going to present, I've actually been able to extract them in different and more crappy ways before we managed to get these very fancy measures. So I'm relatively convinced that this is sort of in there in the data, you know, relatively sort of measure agnostic, because as you'll see, for example, in a second. So this is how it actually would look like if we just look at code change. So this is not the raw data plot. But it is just sort of looking at, you would say, just the size of change. If we consider that change can be measured in terms of the numbers of lines of code that are not the same from one submission to the next, you would get sort of this, which is very much an illustration. And I know some people maybe in other fields than management are not so impressed by the slope here, but this for me is actually quite exciting, because this is as I said, almost a raw data visualization of the fact that we do see some traces of the win, stay, lose, shift thing here. So as people are doing or are performing closer to the best, which would be sort of here on the right hand side. So here is basically, this is the person who's the who has the best score in a given submission. And so as people are approaching to that performance, they are less likely to want to make big changes. And as people are sort of more on the left-hand side, they are more likely to make big changes, because they're basically very far behind. And we can see this also with historical aspirations. We can see something similar to this also just by looking at code complexity. So this seems to be there no matter how you look at it. And again, this is not very sort of processed as much as sort of raw as it can get. We've also sort of, again, looking just at before starting to throw some regressions at you, we've also looked at, you know, can we see that experts indeed do, or how would you, if we look at this code change measure, how do experts actually seem to perform? And we see that even though you can see here that they don't look dramatically different, but and clearly, you know, at its high level of expertise, it's not that much of a difference, as you can see here. But on average, experts do seem to make smaller code changes than sort of non-experts, and sort of basically this lays the foundation for what I'm going to look into next, where we look more in detail into these sort of measures, where we try to see, okay, where can this sort of come from, and so what I could say is that experts are less likely to follow a win, stay, lose, shift strategy. And that is actually not in this table, but it will be at some point. They are simply more likely to, or they will submit more in a given challenge. They will submit more solutions. They spend more time within that challenge. So they're more time active. There's more time between their first and their last submission, and they're also faster to submit. So they're quicker with respect to their first submission. So this sort of goes very much in line with what I would say cognitive science would predict, that experts are quicker to form that initial sort of problem representation, and sort of it's easier for them to come up with the submissions. I would not necessarily have, I haven't predicted at all that they would submit more times, but this seems to sort of be the case. But again, what is interesting here is they're less likely to follow this strategy. Even though they submit more, they're actually less likely to follow this win, stay, lose, shift strategy. So they're less sensitive in a way to feedback. Experts tend to make smaller changes. And this is sort of illustrated by those measures that we were talking about before. So they would tend to actually make more updates rather than sort of these bigger structural changes. Sorry, they would tend to make more, yes, they would tend to make more updates than I need to carefully choose my words here. Then they would take and smaller structural changes, but they are actually more likely to make these changes. So that's where the sort of where I thought that was actually quite interesting. They're more likely to make changes, but when these changes are made, they're actually sort of these ones that I just described here. So they will make more node updates, and then sort of subsequently smaller structural changes. Okay, so now going to sort of a little bit like, this is actually the last finding, and it's a null finding, and I think this is actually one of the ones that I find to be the more interesting when it comes to sort of implications for practice and for theory. It doesn't seem, we couldn't find any evidence that people actually react in any way, or they change their behavior with respect to problem complexity. Now, of course, being that it's a null finding, that's also why I'm not leading with it, but this is consistent with also with research that Stefan Billinger from Odense has found in the lab, that people are not susceptible to landscape topology. And this actually goes counter to some of the research done in cognitive science, at least that I found. And I think this actually has quite strong implications for practice, because at least we know that the near optimal sort of strategy would take problem topology or problem complexity into account. The way we measure problem complexity, by the way, is we actually had a bunch of people from TopCoder go through the different problem statements and assess their complexity based on a number of criteria, and that's sort of the measure that we're using. So these are real problems. We used, and this is where Rinat was very clever at it, sort of coming up with a consensus algorithm. But irrespective of the way we try to, I mean, this is a robust finding according to the different measures that we use for problem complexity. So what would be some of the implications of the stuff that I just mentioned? Well, when it comes to theory in general, we, like, at least my expectation, and I actually have a slide of that I mentioned a lot of times. I really thought, you know, humans are cleverer than rats. I meant that in the sense that they do model-based search, and they should have some kind of problem representation that allows them to navigate the landscape and so on. And they do, but it's not, it doesn't seem to actually work for this, at least in these kind of like real world settings. At least not in the way that I would have predicted. They seem to be better at interpreting feedback. That's why they're doing this sort of, they're not going or they're not reacting according to the win, stay, lose, shift rule. But it doesn't seem, I didn't find any evidence that they would have some kind of meta problem representation that allows them to navigate the landscape in a different way. They are not affected by fixation effects, because I do find that they're more likely to do changes than novices, but they make more or smaller adjustments. So in this, I sort of put together with the fact that they make more frequent changes. I would say this is largely due to the fact that they are just better at being so they do operate in a different sort of chunking space. It's just easier for them to come up with a small tweak and that actually works and test that. So that seems to be what is going on here, rather than novices who probably actually have to spend quite a bit of time in developing a new solution. But that being said, so I would also say that in some challenges where you want a bunch of different approaches, you might actually not want the experts, which is kind of in line with what fixation, sort of the fixation theory would say. The implications for practice are, this is, in terms of practice, this is my most practical work so far. So if you don't think this has any relevance, please don't say it now. But I think in terms of designing these platforms, we know not that much, and especially for TopCoder, who's now trying to sort of build like a proper business model around this. The value seems to come from having a bunch of, in these settings, the value seems to be coming from having a bunch of different perspectives. So if we find that experts are not really that sort of keen on changing their representations, and that people in general are not very sensitive to problem representations, maybe there's sort of but at least my thinking is there should be a way to nudge people into doing things differently, and an awareness that, you know, people will actually tend to do more exploitation, irrespective of the underlying sort of landscape. I think that's all I have. Thank you for listening. I really look forward to your comments and questions.
Comments, questions, suggestions. You can raise your hand in the participant window, but we can also see each other on the screen. And if you have muted your camera, now might be a chance to unmute your camera so we can see who is actually there. Christian, you're first on the list.
Okay, so this is a question regarding the, I guess, the landscape, the whole landscape metaphor, because sometimes it can be a bit confusing that the landscape is both kind of seemingly something independent of the problem solver, but it also kind of change shape depending on the problem solver somehow. But more generally, I was wondering, so when I'm confronted with a programming task, I guess search is a good metaphor. I search a lot, but I wonder if the expert presented with a programming challenge has sufficient prospective cognition to be able to kind of plan the whole path to the end goal, knowing that there will be at least like small local obstacles to overcome, maybe, but maybe search is not the best metaphor for the kind of process that the expert is going through in solving a programming challenge. If the expert is really able to kind of immediately depict or imagine the path going all the way to the solution.
But okay, so let me see if I definitely agree with you that that's what I believe happens, that experts are better at actually imagining how a solution might look like, but without necessarily having pinpoint all the details. But that's basically what my results are saying, that because then they only do, but it's still search, because they do small tweaks, they do test outs, you know, different, maybe they test out different. That's something that I don't know if I haven't captured. I don't know if they test out different parts of the solution in different sort of submissions. Sorry. But that does seem to be what is happening. That's also sort of why I like this finding, that they make smaller sort of tweaks along the way. But it's also the case that it seems to be that they're less likely to change this overarching sort of representation, while it seems that novices, presumably because they start off with a worse representation, they're sort of more likely to do that. But I mean, of course I'm biased. And I think I've also told this to Carsten at some point. I cannot imagine a world in which we can think of problem solving not as search. I'm very biased, and I think this is a handicap. But But I think in this situation, it kind of works. Yes, Andreas.
Yeah, just to follow up on Christian's idea. So it's a very interesting finding that your experts do kind of more of these fundamental structural changes, right? It seems to be less tweaking and then actually something quite fundamental that they try out, even though it may not be necessary, seen from the standpoint that they're at. And I wondered whether this is a place where the search in the landscape metaphor might be kind of, hitting a boundary, because what would be the difference in search, whether you do small tweaks or you do structural tweaks? So in the landscape metaphor, usually if it's a mountain landscape, we're talking about 3 dimensions, and one of the dimensions, the height, is the solutions, and the other 2 are the navigations. But I wonder maybe what the experts are doing is that they are, in a sense, constantly opening up more dimensions as well. So that in a sense, it's not just a matter of navigating the 3-dimensional landscape differently, but at times, so to say, exploring, is it a different dimension that's important? And you could see the structural changes as an aspect of, so to say, trying out a different dimension. Now, if that's the idea, are we not then, so to say, a little bit caught up in the idea of, walking mountainous landscapes when we really describe what expertise is about?
Can you repeat the question?
Yeah, I mean, so the landscape metaphors suggest that it's all a matter of exploring a 3-dimensional landscape, right? And then what you see is that the experts, they do more of these structural changes. And that seems to be something else than just walking somewhere else in the landscape. And one interpretation could be that what you do when you do a major structural change is that you open up another dimension. It might suddenly be a 4-dimensional landscape or a 5-dimensional landscape. Yeah. Or you, in a sense, project onto different dimensions of the n-dimensional landscape that might exist there. And I wonder, your mountain landscape metaphor, is that able to capture that idea that experts may simply be navigating more dimensions or be opening up other dimensions? And that's what it takes to come up with better solutions, not just doing that kind of path search.
Yeah, so I think I really like this. I don't like the 3D. It's also misleading, the 3D representation of the fitness thing. So then I think you are definitely sort of onto something. I've also talked to somebody from organizational literature who's also saying that the speed aspect, the fact that experts are just testing things quicker, this is also actually not captured when we think about the fitness landscape. That is not something that is really, when we say, oh, they're doing just local search. Well, yes, but if they're doing, 100 different moves, while a novice is just trying something out, and it's a different kind of local search. So yeah, I definitely agree that experts are searching differently. I think the problem with the fitness landscape is I also sort of had to accept, it's a very bad metaphor, but it's the best one we have. So I don't know what to replace it with, but I think it's a very good point that this could be sort of a finding that pushes that agenda a little bit more. Let's try and think of something better.
Carsten?
Yep. Thanks very much, Oana. That was very, very interesting and very nice data set that you've came across there. I had one very small question about the early graph that you showed with some raw data on social feedback and number of changes. And I'm probably wrong, but it seemed to me that, that one. Wasn't social feedback, that was calculated as the difference between the individual's performance and the best other performer, right? So the people to the right here have a large difference, right?
Yes.
So if you, I think you had a definition just a while back.
Yeah, no, you're probably right that it's wrong. And
so here, the difference from best coder
Yes, so
minus the sub.
that's a wrong slide. This is sort of correct. That is just a wrong definition on the previous slide. Thank you. Yeah, I just.
So it seems that the people who change the most are the ones who are performing better, right? According to this graph, or
No, it's just the definition on the slide that is wrong.
okay.
Sorry.
All right.
This is my bad.
Yeah, just that kept being in the back of my head with the next results. But just another general comment, if I can remember it. Oh yeah, so this place that you are using, now I can't remember what it was called. What was it called again?
The place?
TopCoder.
Yes.
So the people who submit these things, are they typically working on these things alone, or do they also work in teams?
So the data that I have access to is people working alone. There are also some team challenges, and they actually did some experiments. Some of the people from HBS, where they allowed people to see other solutions and built on top of each other and so on. But the stuff that I have is strictly individual problem solving.
Okay. All right. So that was sort of the starting point for my question, because I think that's something interesting happens once you start to mix these experts with the novices, right? So
I agree.
So the experts are really good, but if there's only experts, they tend to sort of conform around the same local peaks and miss all the global maximum, right? So it would be interesting to compare this data with some of the team data, where if it's possible to identify the composition of these teams. So you could sort of test your findings against what happens when you sort of expand and let these experts interact with novices, and whether they maintain the same search behavior or whether they are positively influenced in a way that they still maintain their speed, but also sort of make bigger structural changes to find the global maximum.
Yeah, that would be, yeah, that's a really cool idea. Unfortunately, they only gave me the individual stuff. I was looking for the collective. But I'm still working very much with TopCoder, so hopefully we can actually do some experiments along the lines that you're suggesting. One of the cool things about this paper is also one of the worst things about it is the data set, because they're completely different problems spanning, I think, from 2007 to 2019. So just comparing, or not comparing, but aggregating this into something that is comparable is actually removing a lot of nuance, and it's averaging out a lot of things. So that's sort of the next step where we actually have access. One of the co-authors is now a senior data scientist at TopCoder. He moved from Harvard to TopCoder, and we should actually have access to do some experiments. And this sounds like a really, I mean, I'm definitely interested in groups. So this seems like an obvious cool step to have different kinds of groups versus individuals. Yeah,
because then there's a whole literature opening up looking into diversity in those groups, or whether they are similar, and it seems groups need a bit of both, as usual. Yeah, I had some other comments as well, but I think I'll leave it here, and maybe I'll send you an email with the rest.
Yes, that would be amazing. Thank you.
Thanks a lot.
Yeah, I just need to unmute myself. And formally, you mentioned that the experts there tend to make smaller changes, but they tend to make more updates and more likely to make changes. But would you say, like, it's actually experts are making evaluations of different ways of solutions, and then just choose the best one as a real problem solving one? So would it be would you say it's an evaluation that is actually tend to be like more likely to make changes rather than like big changes or exceptional changes?
Sorry, I didn't quite get the. Can you maybe
Oh,
repeat a little bit?
yeah. I should pitch it more clearly. So, would it be like the updates? They're actually the evaluation of different problem solving solutions, and they try to evaluate which is the best one. So this is more likely tend to be updates.
Oh, okay, that's a good question. So I would say based on what we tested, but I can't answer that definitively. I can say based on what we tested that it is about the number of changes. It's not about the evaluations. I mean, they do, well, so they do make more submissions, which would suggest indeed that they could be testing different kinds of solutions, which is what you're saying, but they're also more likely to make changes. So maybe it's both actually.
Yeah.
But I can't say definitively because I've only looked, because of computational limitations, I've actually only looked at differences between the first, the middle, and the last solution. Because taking all the differences between all of them, just we can't do that. So I can't say definitively that these different submissions that they are making, they are different trajectories, or you would say different, or like explorations of different trajectories. So I cannot say that definitively, but yes, it's true, and it's a really cool idea that this seems like, or this could be that this is what they're doing, that they're actually trying out different things.
Yeah, that's true, because we can't know it before we're actually evaluating, are these submission things that with slightly changes or just essentially changes like the rest thing. Yeah, so you're right. That's quite interesting about it. Thank you.
Yeah, thank you.
Yep. Any more questions or comments, Carsten?
Yeah, just to follow up on that, want to remind me and us, how is it? You have some competitions where people could sort of test a solution before they uploaded it, but you've only included those competitions where any kind of test of solution is actually uploading it, or how is it?
Oh yeah, so that's true. So there's a lot of variance in these competitions, and one of the design factors there is that in some of them one could test their solutions on their own computers, and in some of them you could only test your solution by uploading it to TopCoder. And for this I haven't actually looked at that for this version of the paper, because there are just too many variables that I could look at. I did do this at some point, and it seems to have an effect on search behavior, but it was rather marginal. So that's also why I was like, okay, well, it could matter, but it's not something that people are extremely their behavior is not extremely impacted by that, or it doesn't seem to be extremely impacted by that. But it's true, we could actually going towards what yeah, I'm sorry if I'm pronouncing your name wrong, but Yakan was saying. So going towards that, I think maybe one could actually distinguish between these kinds of competitions. Yes.
Okay. Any more questions? Or Carsten, please.
Yeah, just a more general follow-up to maybe also push your theorizing or speculation a bit more. So you're basically saying we have a lot of lab research that shows that people do adaptive search. Maybe we overexplore. And then you suddenly have a data set from real life where there's actually meaningful search going on and people have domain knowledge. Is that simply a strong external validity limitation to lab experiments, or is there something else going on that should make us skeptical about lab experiments?
But we are saying people, over-explore with respect to the underlying landscape topology. So we know they are over-explore because in Billinger's experiments, we actually have a simulation that tells us how people should explore, how much people should explore.
Yeah.
And we know they over-explore in the PL or whatever in the
Physics.
Experiment, because we compare it with some algorithm and we get good results. But we don't know, I mean, here we have no idea what the underlying topology is, and as much as Renat and I brainstormed for the last 3 years, we can't find a meaningful way to describe that. So we don't know if people are under or over exploring. We just know that experts do less exploration. So whether that actually course corrects enough, or if one were to take the normative result in the lab at face value, so whether experts actually explore just the right amount, I can't say that.
Mm-hmm.
Okay, any more questions or comments? Well, thanks again, Oana. This was great to see you and great to see you all here. So no IMC seminar next Tuesday, but stay tuned in on the newsletter to see when the next events will be. Take care and stay safe, all of you out there. Bye.
Thank you, everyone.